Today in this video, we will learn about real numbers. What are the different kind of real numbers? What are rational and irrational numbers? What is illicit number system? Okay, and we will take few examples of rational, irrational numbers and illicit number systems. Okay, so let's start with that. So what are the real numbers? Real numbers are the numbers that can be found on the number lines. This includes both rational and irrational. So real number is a combination of rational plus irrational number. Okay. We will see what are the rational and irrational number in the coming slides. Okay. And the real numbers can be positive, negative or zero, which includes the fractions. So in short, real numbers are those numbers which can be which can be any numbers on the line, right? So as I mentioned earlier, so it's a continuous, it's used to measure the continuous quantity, right? So if you take the line, right, like this, then any number, okay, which is there on this, right, positive or negative, those are real numbers. It's a combination of, as I mentioned earlier, it's a combination of both rational and irrational numbers, and it can be represented on as a point on a continuous number line. So any point, be it negative, be it positive or zeros, all belongs to this real number. Okay. What are the rational numbers? So rational numbers are those numbers that can be expressed as a quotient of two integers, right? When I say quotient, right, it's like in a format of a by b, right? If you say 1 by 2, right, it's a rational number. So any number which can be represented as a combination of ratio of two numbers, those are rational number, right? So for let's take the example of it can be both positive or negative, right? Minus 3 by 4 or 5 is nothing but 5. We can represent it as 5 by 1. So b would be 1, a would be 5. Right? Any number which can be represented as a ratio of two integers, we can call them as a rational numbers. Okay, so let's see what are the irrational numbers. So irrational numbers cannot be expressed as a fraction. It cannot be represented as a by b, right? They are non-terminating, non-repeating decimals. So for example, if you say the root 2, right, you will not be able to find a perfect answer for this, right? Just like your pi, right? It's a continuous number, right? 3.14, and then it's keep going on like this, right? So these are irrational numbers. They are non-terminating and non-repeating decimal expansions. That is the characteristic of irrational numbers. Let's take for example of rational numbers. So as I mentioned, it can be represented as a by b. So 3 by 4 would be the fraction. Then 2, which is a whole number, is also a real number because it can be represented as 2 by 1, right? For 0.5, right? So 0.5 we can write it as 5 by 10, right? So again, it's in the ratio of a by b. Okay, b is 10, a is 5. So it is also rational numbers. Irrational number, as I mentioned, right, 2, you will not be able to find the perfect solution for this root 2, right? It would be a continuous going on after decimals. So it's a irrational number. Similarly for pi, it's like 3.147, all those things going on, right? 11, 2.17 thing, right? It's keep going on. You will not be able to find a perfect terminating decimals for these numbers, irrational numbers, right? Okay, so let's take another classical mathematical algorithm, which is illicit division algorithm. So what does it say? It says that any number a and b, if a is greater than b, then there exists a unique integer q and r in such that a can be represented as a equals to bq by r. Okay, so this is for example, let's take 24 and 18, right? Here 24 is greater than 18, right? So I can represent 24 as 18 into 1 plus 6. So any relationship between any two numbers can be represented as a equals to bq plus r. Okay, so let's take for example of this GCD of 56 and 12, right? So 56 can be represented as 12 into 4 plus 8, right? Similarly, I mean, there is one more advantage of GCD is that it would illicit division algorithm is that you would be able to find the GCD of any two numbers using that, right? There is nothing. I mean, normally people get confused between GCD and HCF, but both are same. GCD stand for greatest common divisor and HCF stand for highest common factor, right? So, okay, so let's use this elusive division algorithm to find the GCD of 56 and 12, right? So, yeah, so 56 can be, as I mentioned, 56 can be represented as 12 into 4 plus 8. 12 can be represented as 8 into 1 plus 4, and 8 can be represented as 4 into 2 plus 0. As soon as once you get the 0, then you'd be able to find the HCF or GCD of a number. So 4 is the GCD for 56 and 12, right? Let's take one more example before we close this video. 775, right? 100 can be represented as 75 into 1 plus 25, and 75 can be written as 25 into 3, right? As we mentioned, right? It's a relationship between two integers. So if we take 75 and 25, so here A is 75 and 25 is B, right? So it can be represented as 75 is 25 into 3 plus 0. Now you can see the 0. So 25 would be the GCD or HCF of this number. Okay. So, okay, friends, so that's all from this video. Do like and subscribe to this channel. Thanks.